Director, Inter-University Accelerator Center, New Delhi. Respected Dr. Bolan, our is head of the facility of UDC, and our colleagues, Eliza, Ramus Tripathi from New Delhi. So I welcome you all on behalf of this committee, including now Hari Kadapadi Guwahati, also Professor Kalyan Naik India from IIT Guwahati. I welcome you all on behalf of CSNEs, Vidyarthi and Department of Finance. All for your very presence and in this conference also. With a brief introduction to India International Science Festival, it's my pleasure to make you a disciple of IISF. The 10th edition of IISF, organized Ministry of Science and Technology, Ministry of Sciences and Technology, which started at IIT Delhi in 2015, then organized at National Physical Laboratory Delhi in 2016, IIT Madras Chennai in 2017, 2018 at Indian University of Lucknow, and 2019 in Scientific Convention at Kolkata. We all know 2020 is the year of pandemic, which is called as severe acute respiratory syndrome coronavirus 2, that becomes an outbreak of COVID-19. However, at this critical juncture also, the of IISF in South, it was organized in the in fact, immediately organizing the largest scale at IISF in India. It was held in Research Center for National Research at Maulana Institute, Mani Institute of Health, and 9th was organized in the last 2003 in DBT for the Research Center of Health. And this year, we are at IISF. Research that is unique structure of IISF complements the graduate IIS was also an excellent exhibition for the common market. Yesterday, and Ministry of Science and Technology board for IIS. And so one can say one record a year on students from several different countries in this festival. IIS truly took this festival with a very short amount of participants. IIS was when children from participated looking at the mechanisms of the system. Medical research and so on. I brought in the words, this is not only from the personal or science loving people or collaborators. What kind of impact exactly behind, but the quote is, why not let the school come to decide. What researchers give the experts of other fields, explain the opportunity of interdisciplinary research. And every year, IISF is organized with a special theme. And this year, the theme is transforming India into a science and technology-driven global manufacturing hub. If you look at the past, India made outstanding contributions in the field of science and technology, and also mathematics to the world. Maybe it is the concept of zero, the Madhava Silava Sutra, calculation of pi, or the astronomical contribution to the metallurgy. In many fields, we have our glorious presence. The great scientific legacy again reiterated in the pre- and post-independence era by our great scientific leaders. The scientific sages like Acharya Prafula Chandra Ray, Jagdish Chandra Bose, Ramanujan, Meghnad Saha, Satyendranath Bose, Sir C.V. Raman, Homi Jahangir Bhabha, Vikram Sarabhai, D.S. Kothari, S.S. Bhatnagar, K.S. Krishna, and we can go on and go and naming all those scientific leaders and visionaries. And they have assigned us, they have built for us, and they have assigned us certain responsibilities. This year, there are 25 events in this conference. Ours one is nuclear energy for self-reliant India. India is stepping forward with a dream of becoming a developed nation by 2047. Development means in all sense, including economic and scientific development. I am sure the dream of each one in this house also resonates in the same way. Our dream also resonates in the same way. Out of several factors, one of the important things for the development what we need is per capita energy consumption. This is one of the important factors by which development, basically a developed country is decided. Behind the developed nations integrated with other energy sources, it helps stabilize energy grids, reduce dependence on fossil fuels, and contribute to a sustainable and secure energy future. Particular event, our event, would give a fresh insights into ongoing and emerging research streams of Department of Atomic Energy, along with future technologies on achieving the goal of energy security in India. The sessions in this event mostly would delve into existing nuclear science and technology, its application to health and agriculture and energy sectors, and also will focus on the progress of new and emerging fusion technologies for a transforming change in this country. In our event, there will be plenary sessions, panel discussions, and also quiz program. And definitely, we aim to focus budding young minds to make them aware of cutting edge researchers in nuclear science and technology, to make basically farmers and other common persons aware of the usefulness of the irradiation technology, motivate innovators for startups in related technologies, and also uncover nuclear myths, and that is viral everywhere. And once again, I welcome you all. And just reminding one thing, ISF was inaugurated yesterday, and ISF was deliberately fixed this time, 30th November. This was the birthday of Sir Jagadish Chandra Basu, who is almost known as the father of the Indian modern science. And this year is also the 100th year of Bose-Einstein condensation. You know all Professor Satyendra Nath Bose, who is well known in this world for his pioneering contribution to the boson, basically statistics, boson statistics, and 130th year of his birth centenary. I welcome you all again, and thank you very much.
Thank you, sir, for welcoming the gathering. So now we will call on stage Dr. Ambuj Tripathi, sir, to share a few words with us. So Dr. Ambuj currently holds the position of Scientist H at IUAC, specializing in synthesis and characterization of nanostructures. He holds a doctoral degree from Allahabad University. He had previously obtained his master's degree from the same Allahabad University. His indomitable dedication has proved to be crucial to the advancement of his field.
Please join us in welcoming Dr. Ambuj sir with a huge round of applause.
Namaskar. Good morning. I am Mr. Ambuj Tripathi from IUAC. So Dr. Jajanti has already mentioned in detail about this program. I just will give maybe a couple of minutes brief of this, how we were thinking of planning and this. You see, it is already he mentioned that this theme is self-reliant India. So whenever we talk about self-reliance, one very important point is energy security. And you know, most of the things what we have in India, we have a lot of dependence on fossil fuel, which we don't have. And so one of this possible alternatives is nuclear energy. So the idea was, when this thing was decided, that we should hold this theme of nuclear energy. So we have collected most of this speakers are from this area. So it just one thing how we decided about the speakers. There is some, in some areas there is some misconception about nuclear energy. You have seen in the news, etc. Sometimes there is some plant or something. A group thinks that this is not safe. So this is the whole. Once you go from there, and you will get convinced that this is sort of a necessity, and it's like any source of energy. Somebody was saying electricity, this is what we know conventionally. If you go and touch an electric wire, this is also fatal. So anything energy, anything new technology comes, there are ways to have the safeguards. And it is, as they say, no power is costlier than power. We have to, this is one of the alternatives. Nuclear energy, we have experts from VRC, you see different is being covered. Fission energy, you all know, this nuclear reactors in the conventional sense, which India has now. VRC is sort of a Department of Atomic Energy, so we have many talks from there. You will see the experts from there. They will tell you about that. So which is based on fission, you know, where the uranium or plutonium you break it and then energy is generated. Something futuristic which is being planned, that is the fusion energy, like the lighter elements you take hydrogen and deuterium and then you fuse and then you try to generate energy. What is fusion energy? So we have in India, this is the international, this ITRO, I think you must have already aware of this. ITER, so India is now a partner in that. So we have, which is the group is looking from, is coordinating from India. So we have experts from there. So ITER India, we have Dr. Chakravarti, Dr. Mananjit Singh is from there, and DRC, of course, we have Dr. Vaishali Nayak, Dr. Mani Gai, all the stalwarts from the DAE, they are there. And besides these two areas which are going on, this is also, we are having this sort of a self-sufficient cycle if we are talking about. So one of the new area, again from the student point of view, you must have read the fast breeder reactor. So Dr. Panigai will be covering that. And besides all this type of accelerators, there is also a futuristic thing which is being discussed, which are called accelerator-driven source. So Professor Pandey will be covering some of that. So the idea was that all the possible areas of energy which are at present, which are being planned and which are futuristic. So all of you should be aware of that. And so we got the best of the minds to talk about this. And when this audience was being discussed, we said again we should have the best of minds from future. So that is how we have mostly focused on the school thing. We are glad that in the central registration we saw the interest. I think more than 300 people opted for this session. And of course, since we could not accommodate, we had to cut down to almost 120 from that list. So you are the one. I will request you to make the best out of it, because you don't find such stalwarts in one place for one occasion. And the idea is to give you an idea of what is being done in India and what is being planned in India, and to celebrate what we have achieved and go ahead from there. So again, I will, as a coordinator of the event, along with Dr. Karunakaran and Dr. Jajati, I welcome you all. I welcome all the dignitaries and all the speakers who have agreed to get time to find time to attend this. So thank you.
Sir, for his kind words. Now I would like to call Professor Avinash C. Pandey sir, the Director of IUAC, to share some words with the gathering. So for his introduction, Professor Pandey is renowned for his groundbreaking work on nanomaterials for LEDs, biomedical diagnostics and nonlinear dynamics using ion beams. He holds a master's degree in physics and mathematics and a DPhil from University of Allahabad, which laid the foundation for his exceptional career in material sciences.
Pandey's contributions to the scientific community are truly inspiring. Let's give him a warm welcome and a warm round of applause as we invite him to the
Thank you very much for the introduction. Honorable Professor Shekhar Mandeji, Dr. Thank Dr. Vaishali Nayak, Dr. Tripathi, Dr. Karunakaran, Dr. Jati. And off the dais, I can see Dr. Mananjit Singh is there, Dr. Samit Vagan, Dr. Anupama Chakravarti, Dr. Mani Gai. So this is really a wonderful meet in which you are going to learn more about the nuclear energy. We have been told that this energy has got some side effects. For example, we have learned about the failures of reactors. It is not the case. We can move forward with this. And you know, we plan to be Vikasit Bharat, developed nation by 2047. As per the Human Development Index, the energy consumption should be, that's also a parameter, a measure by which we consider a country whether it is developed or underdeveloped. So what we require, about 2,400 kilogram equivalent energy consumption per capita per year. So that requires about 25,000 to 30,000 terawatt energy production, right? But it is way behind. 1/4 of this capacity which is required to become developed nation or to be considered as developed nation, we have only 1/4 of this. And you'll be surprised to note that only 3% of the energy production which is there in the country comes from nuclear energy. If you compare other countries, for example France, 70% of the energy comes from nuclear energy. So there is a hope, and also there is a challenge for you people to take up this as your own career. Why? Because India already had 3 stages of development of nuclear reactors. The third stage is using thorium, which is India is having a large resource of thorium monazite, which is available. But if we take uranium or other, then definitely the resources will be depleted, and it will not be the case for pursuing nuclear energy based on first stage or the second stage. So a lot of opening is there, and will definitely come forward with the stage 3 of producing energy, nuclear energy, with the help of what we have as our natural resource. Nuclear energy is not limited only to production of energy, but you will also come to know that in food preservation, in medical, the diagnostics, the treatment of cancer is all uses the nuclear energy. Why it becomes important to go for stage 3? That is also to be considered, because the conventional way of producing energy by reactors have got a lot of waste which cannot be dumped, which cannot be stored. Nowadays you can see the phyllox of waste, but for nuclear waste, the waste does not get decomposed in a year or 100 years, more than 100,000 years. That is there, the remnant radioactivity, and again that poses a challenge for the society to come forward with a solution for radioactive waste. So taking a lead in clean energy, accelerator-driven sources for producing energy is a new hope. I'll be talking about more tomorrow how we can go forward in accelerator-driven subcritical systems. So that is all stored in the future for you. It is right time that you have opted, and I was happy to note that more than 200 students, they opted for nuclear energy, for self-reliant India. So this is again a momentous occasion. Maybe one of you will be leading some of the nuclear power plants in coming days. The modular plants which are likely to take place, the old, aged, obsolete thermal power plant, because coal is again another scarcity in our country, and also you might also greenhouse gas emission is minimal, nothing. So that way, the clean energy, safe energy, and using our own resources to become self-reliant, to become a developed nation, that is a hope which we need to foster together by joining hands. Thank you, ma'am.
Thank you so much, sir, for your words. Our next guest of honor is Dr. Vaishali Naik, the head of the Radioactive Ion Beam Facility Group at VECC DAG. She is a graduate of the prestigious BAR Training School and holds her postgraduate degree from the University of Pune.
Dr. Naik's expertise in accelerator physics and her exemplary achievements such as the DE Scientific and Technical Excellence Awards have made her a prominent figure in her field. Let's warmly welcome Dr. Vaishali Naik.
नमस्ते। मंच पे उपस्थित माननीय अतिथिगण, मेरे सामने बैठे हुए वैज्ञानिक कर्मी और छात्रगण, आप सभी का स्वागत है। इस इंडिया इंटरनेशनल साइंस फेस्टिवल ये साइंस का कुंभ है, और मैं अपनी तरफ से इस IISF के जो आयोजक हैं और विभाग, इन सब का मन से अभिनंदन करती हूँ कि उन्होंने पूर्वोत्तर भारत के इस प्रथम साइंस फेस्टिवल का आयोजित किया और व्यक्तिगत रूप से मैं भी बहुत आभारी हूँ कि मुझे इसमें सहभाग लेने का सौभाग्य प्राप्त हुआ। परमाणु ऊर्जा विभाग और मेरी गृह संस्था कलकत्ता के साइक्लोट्रॉन केंद्र की ओर से मैं आज यहाँ पे उपस्थित हूँ। हम ये में सदैव से ही आत्मनिर्भर भारत की ओर प्रतिबद्ध रहे हैं और निरंतर अपने कारणों से विकसित भारत की ओर अग्रसर हैं। हमारे विभाग का प्रमुख कार्य परमाणु ऊर्जा तकनीकी यानी कि टेक्नोलॉजी तथा लोक कल्याण में परमाणु तकनीकी के अनुप्रयोगों का रहा है। न्यूक्लियर रिएक्टर तकनीकी के साथ साथ हम लोग पार्टिकल एक्सेलेरेटर तकनीकी जैसे कि साइक्लोट्रॉन, मेडिकल साइक्लोट्रॉन, लीनियर एक्सेलेरेटर और इसके साथ साथ बेसिक साइंसेस यानी कि मौलिक विज्ञान जैसे कि न्यूक्लियर फिजिक्स, हाई एनर्जी फिजिक्स और मटेरियल साइंस इसमें अनुसंधान का कार्य करते हैं। इसी कार्य को हम अत्याधुनिक तकनीकी से और भी सशक्त कर रहे हैं। आज मेरे सहयोगी आने वाले सेशंस में इसी प्रवास के कुछ अंशों को आपके सामने रखेंगे और आपको इस लेटेस्ट फील्ड से अवगत कराएंगे। मैं फिर एक बार आप सभी का स्वागत करती हूँ और आज के सत्र न्यूक्लियर एनर्जी फॉर सेल्फ रिलायंट इंडिया आप सभी बढ़ चढ़ कर इसे देख बहुत ही खुश हूँ और इसके सक्सेस की थैंक यू।
Thank you, ma'am, for your kind words. It is our privilege to introduce Sri Sunil Ganju, the Honorable Secretary of the Atomic Energy Commission. Sri Ganju is a graduate from Regional Engineering College, Srinagar, with a degree in Chemical Engineering.
So with his extensive experience and leadership, Sri Ganju has been instrumental in shaping India's atomic energy program. So let us warmly welcome Sri Ganju ji to inspire us with his address.
Thank you very much for these nice words. It really makes me feel proud that I have been honored by these words. Distinguished guests on the dais, faculty members from the IIT Guwahati, the organizers, dear students. It's indeed a pleasure for me to be here today in many ways. First of all, it happens to be my first visit to the Northeast in my maybe 35 years of career. And then when I come to know that IISF is also it is the first time when IISF is being celebrated here, it doubles the joy. I come from the northern part of the country where Kumbh actually means the confluence of spiritual rituals, if I can use that word. But here it is a Mahakumbh of science. And it's indeed a blessing for all of us here to be able to immerse in the knowledge. I'll say it's an ocean here. And I'm so glad that all the students are here. When I saw all the students, I was wondering, and all our previous speakers have also mentioned, how so many of the students are perhaps getting interested in nuclear. Then I thought perhaps everybody must be thinking here that we will be talking about bombs, because that is what nuclear is associated with. Nuclear got a bad name because it came into existence, literally, with the Hiroshima and Nagasaki. So perhaps everybody thought that perhaps we will be telling some things about the bomb, how to make the bomb, and do all these type of things. But then nuclear is much beyond that. As a student, maybe you will have to perhaps go back into history, try to study how nuclear started. It started, of course, in an experiment in the University of Chicago, which was called the Chicago File Experiment. I think it was way back in 1942. Then it took up, of course, the research which went primary, that is how we call it the Manhattan Project, where this research, a secret research on nuclear started. But slowly, when mankind or humanity realized that nuclear is just not destruction, energy can always be sort of controlled for much more meaningful purposes. And the first purpose for it was nuclear power. One of our colleagues already told that no power is costlier than no power. So that was the essence with which the program in India also started. Dr. Bhabha went ahead with this atomic energy program. The Atomic Energy Commission was formed. Then the Department of Atomic Energy was formed. And today, into the 70th year of our organization. Of course, the Atomic Energy Commission is more than 75 years old now. The idea behind this, all this was basically to put India on security in terms of energy. We talked about the next.
Under Pragya Bharat, we had exciting session in the morning. This is also going to be very exciting because now we are going to listen from the experts on renewable energy, which is an important area, and government also has been pushing various encouraging policies and programs with the targets for reaching Vikshit Bharat 2047. So may I now introduce the chairman of this session. The chairman of this session is Professor S.P. Gaun Chowdhury. Professor S.P. Gaun Chowdhury, an electrical engineer from Jadavpur University, is an internationally acclaimed expert in renewable energy, a pioneer of solar photovoltaics and mini grid systems. He introduced India's first 2 megawatt-hour grid connected solar power plant in Asansol, West Bengal, and he also designed the country's first floating solar power plant in 2014. His innovative contributions such as micro solar dome have transformed energy access for unprivileged communities, earning global accolades like the Ashad Award UK and Euro Solar Award from Germany. Dr. Gaun Chowdhury is also a visiting professor at IEST Shedpur, chairman of International Solar Innovation Council, and a member of India's Energy Expert Committee. May I request Professor Gaun Chowdhury sir to come to the dais. Now I would like to introduce Dr. Anita Gupta madam, who is going to give the theme introduction. Dr. Anita Gupta madam is the head of the Climate, Energy and Sustainable Technology Division at Department of Science and Technology, Government of India, and she is a distinguished leader in clean energy and sustainable technology advancements. She holds a PhD from IIT Delhi. She brings over 28 years of experience in driving transformative initiatives such as National Initiative for Developing and Harnessing Innovations, NIDI, popularly known as NIDI program, and establishing over 175 technology business incubators nationwide. Dr. Gupta has played a pivotal role in India's clean energy transition with the key focus areas including solar energy, hydrogen, energy storage and carbon capture technologies. Representing India in mission innovation, she fosters global collaborations and partnerships. She contributes, her contributions make her a leading voice in innovation and entrepreneurship and climate change solutions. May I request Madam to be come forward.
Thank you, Suresh, and welcome once again to all the esteemed dignitaries who are going to be part of our lead talks today, as well as panel discussion which has to follow. So needless to say, we have embarked on the Pragya Bharat theme, which targets the new frontiers of science and technology. Yesterday we discussed about the role of quantum, AI, and communication in fast forwarding our technological progress in our mission and vision to be a Viksit Bharat by 2047 when India turns 100. This second theme today is targeting, as you know, renewable, environment and sustainability. I think lot has been talked about why we really need to focus on renewable energy in a greater and more accelerated manner, because India, as a most populous nation as well the 5th largest economy, aspires to be a developed nation. So as we move forward, we have to strike a balance between what Mr. Pant also, Dr. Pant also has talked about. One of the critical factor is going to be how do we really integrate economic development, energy independence by 2047, as well as ensure ecological balance and environmental sustainability. And believe this is not going to be easier. It is going to be really very daunting and challenging task for all of us. But if we are aligned with the shared mission and purpose of making our India a developed nation as well as a responsible nation who want to make India much more cleaner and greener for our future generations to live, because we are currently the 3rd largest emitter of carbon dioxide, and carbon dioxide is the biggest contributor of global warming worldwide. And if we really want to limit the rise in temperature, our PM has already given our agenda. It is a Panchamrit in the form of 5-point agenda, because our immediate goal post is going to be 2030. 2030 we have a set agenda, as in the previous presidential talk by Dr. Padhi. We know we have to really bring the 50% share of renewables in our total installed capacity. So currently we are, as per the Central Electricity Authority data, we have crossed I think 200 gigawatt installations for clean energy. Current installation is going to be through the fossil fuel. We are actually contributing to less than 70%. As we rapidly progress in terms of industrialization, urbanization, we have to be equally wary about the sustainable development goals. And that's how we want to make the planet more livable. In terms of, if we really analyze the 17 SDGs, we have 6 ones for clean water, 7 is for clean, 7th is for clean energy. We have 11th one for sustainable cities. At the same time, we have to really be responsible enough in terms of responsible consumption and production. So that's why sustainability comes into play. We also have another SDG of climate action, which is SDGs 13, and that's how collectively each country responds, be it a nation, be it a society, be it an organization, and be it any individual. As society at large, we owe so much to our planet, and we have to really play an active role and do our bit and all sort of measures. And since we largely represent the scientific fraternity, most of these solutions, which are pressing solutions, pressing needs for country, we have to come out, and all these solutions have to be carefully thought of, driven by science, technology, innovation, and also if we really want to translate these solutions to the wider masses, we have to have the startups, entrepreneurship, technology commercialization, all these aspects come into play, where the technology readiness level of various R&D which is happening across various institutions needs to be backed by the kind of good mentorship, right investment, and then it needs to be translated. We need to see that whatever solutions we are actually bringing to the table at lab level, how many are really fit enough to be translated to market. So, and these kind of solutions which are deep tech have to be really taken to next level, and every such kind of development has to navigate the valley of death. So when we talk of any new technology which really comes into being, comes into play and sees light of the day, these kind of technologies, a lot of push and thrust initially has to be given by government, and that's why DST is playing a very pivotal role in driving the entire gamut of you can say research and development. We are technology agnostic, so we are covering various facets of technology. Yesterday we talked of the National Quantum Mission, which is going to be the game changer in the years to come. If we really marry the quantum technologies with AI, communication, and it is going to change the face of the way healthcare is being provided, and how industries are being actually, how climate change modeling is done. So it has a huge, you can say, it will have huge bearing on the future course of all these technologies. And another aspect which I have not covered is how, as India progresses, it is said that 60% of India is yet to be constructed. If we are really aspiring, the huge bearing on the construction sector, steel, cement, these are the sectors which emit lot of carbon dioxide. What are the technologies? We have carbon capture and utilization, the new fuel of the future, hydrogen. So there will be enough transition from the current mode of IC engines which we normally drive, how these are going to be a cleaner mode of transportation in terms of switching over to and transitioning towards the electric vehicle, electric mobility. And then also we have to really, when we transition to any new domain where India has to really adopt and prepare itself, we as a government, we have to create the requisite ecosystem. So ecosystem will entail all pillars, strengthening our R&D capabilities, improving and empowering our institutions. It will also have what are the initial funding programs, how do we really support new kind of technologies, and then we need to skill and upgrade the skills of our youth and prepare our future generations to adopt to those technologies and champion those technologies for the future. So these are going to be our challenges, but given the vision, we are all united by the common problems. At the same time, we are all united by our unique strength which India possesses. And I think the sessions which have been really aligned for today's talks and the subsequent two themes which are going to be covered later will be so enriching and enlightening for all of you. I think these are the clear takeaways for devising our future roadmaps for India's, and collectively I think we need to strive for development-led, inclusive and sustainable clean energy transition. So that is going to be our motto, because in India we cannot leave anyone behind. We have to include women, so we have to include and reach out to grassroots, rural masses. So inclusive and inclusive is an important agenda in our development pathways. And in terms of decarbonization, we have a series of, we have really picked the best minds in India, which represents a cross-section of both academia as well as industry. In all these sessions, my colleague Suresh has played a very good role in mobilizing all these experts, especially from the industry side, and you will get a good flavor how India is doing and what needs to be done. There are, in our march towards Viksit Bharat, we have some challenges to cross, and collectively, if we really take a good stock of the situation, we'll be able to navigate and meet all the targets. The first targets have a series of we have really organized the energy independent. We have a series of ultimately we have really where we tackle all the key areas of decarbonization, attaining net zero by 2070. That's a overarching mission for us, and as also shared by Suresh, DST and in particular our division is driving the global platform from India side, that is Mission Innovation, and we are aligned with, and actually DST is a par in terms of all the research agenda in terms of clean energy, and also we actually have formulated many programs which are on public-private partnership mode. In fact, we have played a pivotal role in coming out with the white paper on electric mobility and a detailed reports on battery technology, the powertrains, machine drives, and in terms of electronics side, then also on the charging infrastructure. Anyone can go and visit our website. All these are available publicly online. And this report has led to translation in action. We have now ANRF, Anusandhan National Research Foundation, for driving the research in the country. And the first, very first mission which has been launched under ANRF is on EV. So the call is ending on 5th of December. Anyone who aspires can really go through. This is a really a good call made out of our white paper's recommendation, and there's an active partnership of industry also envisaged under that. With all these insights and sharing from my side in terms of DST is into virtually all domains of climate change adaptation and mitigation. You talk of the solar energy, you talk of, you can say clean coal technology. We are largely fossil fuel dependent. So we have created many center for excellence which actually are focused on all these areas, solar energy or clean coal technologies. We are coming up with carbon capture and storage and utilization. So, and also on the battery technology, currently India does not have cell manufacturing facility. All cells are getting imported, stacked, and that's also, if we really aspire to be indigenous and developed, we have to really carefully come out and direct our funding and investment to areas where India wants to have a supremacy and technology prowess in those areas. So Center for Excellence in various domains where India is not having, will be keen to put up such kind of infrastructure and facilities. Then we have on the building energy efficiency, we have actually, we have so many international partnerships across the domains. So in SEPT, Ahmedabad, in IIT Roorkee, we have the state-of-the-art building energy kind of interventions we have created. Energy storage, then EVs we are working on. So entire gamut of clean energy and climate change adaptation. We are actually responsible for managing two national missions. First on climate change. First is on sustaining Himalayan ecosystem. So entire northeast and Himachal and Uttaranchal, J&K, they are part of our activities on climate change. Then we have national mission on strategic knowledge on climate change. We have created close to 20 COEs across IITs, ICERs, only to study on the climate, whether for costing, vulnerability study, risk management studies, and how do we prepare our society, whether there's a strong nexus of climate change with health, with food security, with water availability. So all these, and also involving women, because lot of, you can say, the normal life is disturbed when we have extreme events like floods and all. How do we prepare our communities to deal with such kind of weather-related extreme events? So all these are part of, so entire gamut of activities are under fold, but we will invite good suggestions what needs to be done much more, which enables us to really formulate our programs to suiting to the pressing needs of India at large. So with these words, I welcome you once again. Needless to say, we all have a collective role to play in making our planet much more greener and cleaner. Thank you.
Thank you very much, madam, for giving an overview of government's aspirations and the initiatives taken by Ministry of Science and Technology in fostering this area. Now, may I now request Professor N.B. Padi to give the first keynote address on the topic battery energy storage systems, integrated AC DC smart grid, a practical case study. May I request Professor Padi sir to come forward. Thank you.
Can you please upload the presentation? Yeah. Is it ready? Excellent presentation view. All right. So, very good morning. The session chair, Professor Gaun Chaudhary. With your kind permission, ideally, I'm supposed to acknowledge those who have helped me to be on the dais standing before you. It won't be a fair idea not to acknowledge. This talk is basically and perhaps mainly supported by Department of Science and Technology. All the funding which has been derived from Department of Science and Technology, and thank Dr. Anita Gupta for giving extreme support and guidance both administratively and technically to grow in the field of Green Power Future Mission. I'm happy that on behalf of Department of Science and Technology, I have been given the opportunity to collaborate with 22 countries across the world and representing DST along with Dr. Anita Gupta in Green Power Future Mission now, and it has started as a smart grid mission in the past. So the main responsibility of me is to create a complete smart grid ecosystem within India on behalf of DST, and that is what I'm doing as on today, and probably we'll just come to know the outcome of this project. Probably this is one of the success story of Department of Science and Technology, where equal amount of funding has come from industry, that is ABB, couple of years back. I also, wish to thank IIT Roorkee because my director, Professor Pant, is here. Because IIT Roorkee also supported me a lot to execute my thought process in real ground. Because it is not about funding, but also you need to have support from the administration to execute some of your real challenges. So how do I move with the slides like this? Okay, got it. So what I'm going to talk today, in my today's address in the inauguration session, most of you were there, but I could see some of you are very new. So the thought process is, as I told you, we do have a lot of energy requirements because I belongs to a very humble family background. I still remember when I was a young kid, we had only one fan in the home, which is almost 45 years back. So I still remember that we all used to be hungry to get into that room to have some relaxation from the fan, and used to all, kind of together spend the whole day. But today, we do have 4 air conditioners, and we utilize only one bedroom and one drawing room. So 2 air conditioners are used only 6 months in a year, and 2 of the air conditioners which are not being even utilized. Okay? So all the time I believe that we as Indian, most of us are middle class or upper middle class, and we have the aspiration to have comfort in our life, and that is nothing but energy. And there is nothing wrong. There is nothing wrong to be aspiration towards a comfort life, which is natural. But how do you meet out that comfortness? That comfort has to come through serious energy availability, and the gap between availability and the desire must be minimized. And that is the role of technocrats, to plan and accommodate in such a manner so that the aspiration is being met without giving lot of challenge to the country. All right? So, there is a beautiful story in my life actually. Till 2012, I was a very serious lab researcher, keep on working and being satisfied. But 2012, I was addressing a very high level invited talk in United States, and the talk was, India has never experienced blackout. And the moment I came to the airport, before boarding to India back, I got a phone call from my wife that there is no power in the home for last 2 days. I was very disappointed. I was very, I'm a Pakka Indian, I take proud of, even with a lot of difficulties, but still we are doing some good things that cannot be denied. Because till that time, 2012, We have never had a serious blackout in this country. Perhaps US experienced couple of prior to us. So then I said, what to do? And that time, fortunately, my director at that time, IIT Roorkee, given me the first responsibility to decide how much PV solar need to be installed in the campus, madam. उस टाइम पे एक्चुअली नया नया 80% का सब्सिडी मिल रहा था, तो मेरे को रिस्पॉन्सिबिलिटी सौंपा गया कि आप डिसाइड करो कि कितना पीवी लगाना है और कहाँ लगाना है. Yogesh will be very happy to know. I just spent more than a year taking all the colleagues with me and decided and presented to my director that 1.73 megawatt of solar need to be installed. And immediately the project was sanctioned. With 10% money, we could put 1.73 megawatt in the campus. And this is just prior to that blackout. So I asked my wife, actually, when we have 1.73 megawatt of solar in Roorkee, why the accommodation, campus accommodation is not having electricity? And to be very honest, I openly accept, I did not realize where we went wrong. क्योंकि हमारे पास PV है, solar है, नीचे बल्ब नहीं जल रहा है, क्या कारण है? And then I realized that if the grid is not there, then you cannot generate PV solar. तो आज की डेट में जो मैडम ने बताया, and the country's vision to make this country 40 to 50% renewable, it is fine. But when there is a grid failure, those 40% of renewable may not be able to generate a single watt of power, or those 40 gigawatt of energy or 100 gigawatt of solar energy may not be able to cater a single bulb. So what need to be done? This is not your problem, this is the problem of us. So we need to go for a technology where all the PV power need to be evacuated even during blackout. So then I landed in India, 2012, I wrote my first proposal to DST, not referring to anything, but the exact case study that how we can evacuate renewable energy of India when there is a grid failure. And I am very happy, the first ever close to $500 million US project which has come to IIT Roorkee as an international project. And from that day onwards, we never stopped. It is flooding and we are doing a great job. So this is the story and background. So what I wanted to highlight, the India energy sector, we are great. And before, give me a alarm actually before 5 minutes of my talk, so that I'll stop, okay? So this is what is important, as we all know. Let me not spend any time in this. But this is a picture which is very, very important today. And as you could see from this diagram, that India is quite aggressive in the renewable energy integration, and that we keep on adding, and there is no other way out. I do have my own definition why India is going for PV. Sometimes we talk about we are into green, but I do see there is a bit of compulsion also. The reason being, thermal power plants cannot generate energy because of global challenges and India's vision. Hydropower projects are almost 50% obsolete, and due to green corridor clearance, even if you go for a new proposal, it is very difficult to clear. Most of the hydropower projects take 7 to 10 years, though it is needed for actually 2 to 3 years. So we lost hydro, we lost thermal, which has been taught to us during our undergraduate. There are 2 types of power plants, but today both are non-operational. And what is left with us? Nuclear, and we do not carry our own technology. So there are a lot of global pressure to get into free drive into nuclear technology. So what is left? The only thing left for me is renewable. So one way, God is very kind. That means the country demands renewable and we also need renewable. The advantage of renewable energy, that very quickly in 5 to 10 years time we can add huge amount of green energy, which is not possible in case of thermal as well as hydro. So this is a good idea. But my worry is this pillar. My worry is this pillar, which says that 2024 to 30, the first yardstick, as Dr. Anita mentioned, and 2047, that is what the Viksit Bharat goal. So what is going to happen? Just I tried to analyze yesterday night, and I could feel that there is a small growth, which is not small but significant, but 2047 goal is very, very huge. So there is a concern today in our global Green Power Future Mission discussions, which is supported by the Department of Science and Technology. We have resolved that each and every country of the world must aim to have 100% renewable energy. European countries are quite small, they can become purely renewable, but country like ours cannot be purely renewable. But we aim to be renewable, means 20%, 30%, 40%, 50% we need to accommodate. Now many researchers in global forum asked me what percentage of renewable that we must go for, because country like Germany had lot of difficulties of renewable integration, but I said India had no problem. You know why? Does India don't have any problem of renewable integration? We have 10 times more problem than the global world. But as in today, we are extremely hungry. We are extremely hungry. So when you are hungry, you can observe anything. Because the middle class aspiration of energy is keep on increasing, so the energy demand is keep on increasing, so I can put lot of renewables in parallel to increase requirement, so that we can observe all the renewable energy for next 5 to 10 years. So which become a challenge for the global world to make 100% renewable world or towards renewable world integration, but India happened to be a luckiest country which can observe any amount of renewable for next 10 years. But the problem will start between 2030 to 2047. So Viksit Bharat पहुंचने के लिए इतना आसान नहीं होगा जो 2024 में है. So I am just making you prepared, my dear friends. I will be retiring in next 8 to 10 years. But you people must solve this problem in 2047 and witness that this country is not without power. Am I right? There are so many technical issues, I am not getting into that. So when you have majority of the renewable power integrated, then you have to shut down some of your thermal power plants and hydropower plants because of excess renewable. But after 1 hour, I have to invite all those huge power plant to switch on, which is not possible because they don't have that much ramping to increase from 10 megawatt to 100 megawatt in 60 minutes. So आपको क्या करना पड़ेगा? एक तरफ से थर्मल पावर प्लांट को डीरेट नहीं कर सकते हैं, उसको चलाना है, और जब चलाएंगे तो ये जो सोलर पावर मेरे पास एक्सेस अवेलेबल है उसको डीरेट करना पड़ेगा, which is crime to me, because having renewable energy not evacuating 100% is not in a good spirit, sir. So that need to be done. So what we need to do, we have to make sure all the energy that is being, each kilowatt is being generated from renewable today because of its need, but in 2047 we will have excess. We must also try to understand 2047 एक किलोवाट को हमको यूज करने की भी कैपेबिलिटी और क्षमता बनाना चाहिए. Good. So 2047, when you have huge amount of renewable energy, but 2030, let us focus on 2030 now, and then you people can dream from 2030 to 47. So just I am making you scared by giving pressure that 2047 में ये डर आने वाला है, आप लोग तैयार रहिए, ठीक है? Good. So क्या होगा जब actually when you integrate renewable energy, so this is the load curve of India. Morning I told you there are two peaks that we normally experience. One is at that corner in the evening hours, and this is in the daytime. But the renewable energy, especially PV, which is available to me, and they are available during 7 AM to 7 PM. और takers are very limited. लेने के लिए उसको ज़्यादा लोग नहीं है. तो अभी क्या होगा आप देखेंगे 10% penetration, 20% penetration, 30, 40 तक हम लोग safe है. But the moment you penetrate 50% of renewable energy, you have nothing to do. And 60, 70 जब बन जाएगा, you become tired. तो आपको क्या करना पड़ेगा? You have to give up those renewable energy which will be available to you plenty after 2030. So अब से हमको टेक्नोलॉजी तैयार करना पड़ेगा. तो मैंने एक छोटा सा अटेम्प्ट लिया कि जब हमारे पास एक्सेस रिन्यूएबल एनर्जी होगा तो मेरे को क्या करना चाहिए. And then in the meantime, that is what the national vision. But रुड़की की laboratory में रात 12 बजे एक छोटा सा experiment करते हुए 2012 की दिसंबर के आसपास एक रिसर्च स्कॉलर ने मेरे को बताया कि हमारी लैब की वोल्टेज 275 है सर. I'm talking from my heart today. 275. I said 275 in Roorkee laboratory? Impossible. 20 करोड़ की इक्विपमेंट हमारा जल जाएगा. क्या करना चाहिए? At that time I had 20 odd PhD scholars. सबको बुलाया, इन्वेस्टिगेशन किए, कुछ सुराग नहीं मिला. But finally, suddenly we reserved that जो PV panels हमारी rooftop में लगा था, they are giving me huge energy. But there is no taker. Summer vacation था, बच्चे घर चले गए थे, लेबोरेटरी में प्रोफेसर नहीं आ रहे थे, डिपार्टमेंट की लोड 0 हो गया था और पीवी एनर्जी. तो हमने रियलाइज किए कि देयर इज सम लिंक बिटवीन पीवी एंड द सेफ्टी ऑफ द कैंपस. तो हमने एक्चुअली प्रपोजल बताया कि उस एक्सेस एनर्जी को, बिकॉज यू नो व्हेनेवर देयर इज एक्सेस एनर्जी दैट विल इंक्रीज द वोल्टेज एट दैट पर्टिकुलर पॉइंट व्हिच इज डेंजरस. सो आपको एक्चुअली लोड बढ़ाना पड़ेगा. लोड कैसे बढ़ाऊंगा? एक्चुअली लिटिल बिट ऑफ डिस्ट्रीब्यूशन कर सकते हैं. देन आई रियलाइज कि व्हाई डोंट वी स्टोर इट, why don't we store that energy? So that was the first proposal where we decided that excess energy during a particular hour of the day need to be stored. So that is my motivation, which has come up over a period of time, and whatever I'm talking to you is just a learning. So what was the first problem I have realized is over voltage fluctuations, which is not there in textbook, but this is the experience that we have learned. And then a specific problem about unable to operate during island date. जब grid failure हो गया था, रुड़की में power नहीं था. All right? अभी the same kind of research I am experimenting at MNIT Jaipur campus, and probably we are working on a new thought process, how the technology between IIT Roorkee and MNIT Jaipur can be synced to go bigger in long term, and probably very soon we'll be requesting DST to support on a proposal in jointly with IIT Roorkee and MNIT Jaipur's collaborations. So what we need to do now, अभी 2017 से 2024 के अंदर मैं थोड़ा प्लॉट कर रहा था और देखा कि काफी रिन्यूएबल एनर्जी इंटीग्रेशन बढ़ गया है देश में. ऑलराइट, सो हमको क्या करना पड़ेगा? उस एनर्जी को हार्नेस करना पड़ेगा, उसको ग्रिड कनेक्टेड एज वेल एज आइलैंडेड मोड में ऑपरेट करना पड़ेगा. सो व्हाट आर द प्रोग्रेस प्लान? The biggest challenge when I talk to industry partners कि during grid failure why we are not able to evacuate PV, तो मेरे को ये बताया गया कि there are control mechanisms which is costing at least $500,000 to evacuate your PV during grid failure. So then why not we create a grid? So we thought that the battery storage can be an example of a grid. So first of all हमने system को model किए, एक academic campus को actually completely A to Z, and Professor Pant will be very happy to know IIT Roorkee had no system data available at that point of time, because system तो चलता है लेकिन आप पूछेंगे लाइन की R क्या है, X क्या है, सबस्टेशन डाटा क्या है, वो नहीं था. और आज की डेट में हमारे पास IEEE US मॉडल की पैरेलल में IIT Roorkee की मॉडल तैयार है, which has been lab validated, and now we are developing the same thing for MNIT Jaipur. तो एक्चुअली एग्जिस्टिंग हमने मॉडल बनाए. बनाने के बाद जब स्टोरेज डिवाइस हम कनेक्ट करेंगे, दैट इज वेरी वेरी एक्सपेंसिव, दैट इज वेरी वेरी एक्सपेंसिव. तो उसको कहाँ लगाना है? एंड वी नीड मनी. सो फॉर्चुनेटली वी अप्रोच DST, and DST provided 5 CR approximately. Then ABB provided another 5 CR of equal. Then we signed an MOU, and that battery is still operational in the campus of IIT Roorkee. We identified different important locations where the battery can be connected, but डर इस बात की है कि 1, 2, 5 किलोवाट आवर की बैटरी तो रीजनेबल होता है, but when it is 250 to 300 kilowatt hour, the battery size will be equivalent to a truck, and when you charge that battery, there could be a catastrophic challenges. The whole system may burn. No distribution company in the country will allow you to experiment your research by putting their system in risk. But my institution was kind enough to permit me, and today you'll be surprised to know our lab is directly integrated to 8 megawatt real system of IIT Roorkee. and this lab is known as Admire Lab, and we are probably one of the smart academic campuses where the laboratory Admire Lab of mine is integrated to a 8 megawatt system, and touch wood, it is working for last 5 years. Every day we give energy to the system, we take energy from the system, so it is no more a laboratory toy, but it is a real system. Now, so we have carried out power hardware in loop simulation, where we imagine that there is a huge battery which is coming to play at a particular location. So uski 1/100th छोटा सा
आप लोग डाउनलोड
School for Artificial Intelligence and Data Science being established, and once again I am very privileged to be the founding head of that center and getting the complete grant from United States and establishing it at IIT Roorkee for more than 25 crores. And being the founding head, the second location happened to be in the old humanities department. वो भी actually एक kind of God's blessings था. दोनों डिपार्टमेंट साइड टू साइड थे, और मैं थोड़ा सेल्फिश भी था कि दोनों डिपार्टमेंट में बैटरी लगाऊंगा, एंड आई कुड एबल टू यूटिलाइज 25 crore investment for the department and 10 crores investment for the R&D grant, and these are both next to each other. I will tell you why I am so lucky in this country to experiment this test actually in an organization where both the batteries are located next to next. I will tell you a challenge, and Gaun Chaudhary Saab will certainly appreciate what are the issues and how this can be addressed. Probably we can go a very, very long back. Many of us actually not realize the scope of this growth. So what we have done actually, we brought, so I'll now quickly get into the case study due to sort of time. So IIT Roorkee जो टेस्ट केस हमने जहाँ ट्राई किए थे 2021-22 की बात है, we have 21 substations, 8 megawatt peak and 3 megawatt actually minimum peak, और हमारे पास 2.7 megawatt PV इंटीग्रेशन आज की डेट में है, और 35 लोकेशंस में वो डिस्ट्रीब्यूटेड है. आई एम अगेन वेरी हैप्पी टू से that I have been again made the nodal officer to add the extra 1 megawatt of PV in IIT Roorkee campus. So completely 2.73 installation. I mean, the team knows in and out where it has been established, their positives, challenges, mitigation issues, and they are being integrated to the campus. So this is how the distribution system look like. And can you see few black boxes, my dear friends? कुछ छोटे छोटे black box दिखाई दे रहे हैं आपको? How many black boxes are there actually? 1, 2, 3, 4, 5. 5 है? 6 है? I think this young fellow must tell me. How many black boxes? 5. I think very, very intelligent. What is your name? How old are you? 17-year-old boy could identify there are 5 batteries in my diagram, and till today not even a single audience could able to answer there are 5 batteries in this network, because they are so distributed. So these are the 5 distribution points we have identified. Means we also made IIT Roorkee prepared for next 10 years. जब तीसरा, चौथा और पांचवा लगाना है तो कहाँ लगाएंगे, कैसे लगाएंगे, उसकी बारे में भी रोड मैप तैयार है actually. Whenever we get more money, we can go for third, fourth, fifth. I am very happy that Ogesh is with us, who is a battery expert. Professor Panth is there, who is an administrator. So probably this dream will one day come true with the support of DST. So then हमने जो दोनों केस स्टडी बनाए actually, this is the campus, rooftop, as you could see, and finally we are into, this is my first microgrid. So what has happened, the electrical engineering department has a load of 111 kilowatt, we have rooftop solar of 70 kilowatt and battery of 200 kilowatt hour, but exactly it is 272 kilowatt hour, but we are operating it up to 200 kilowatt hours. तो हमने तो एक्चुअली लोकेशन आइडेंटिफाई कर ली, इलेक्ट्रिकल डिपार्टमेंट में 5 करोड़ का बैटरी रख दी, और आई वाज वेरी फॉर्चुनेट गोन साहब, डीएसटी ने मेरे को स्वीडन भेजे थे एक्चुअली एक ऑफिशियल मीटिंग के साथ. हर्षवर्धन के साथ एक्चुअली हमने स्वीडन में बैठे थे और उस राउंड टेबल में एक्चुअली एबीबी की स्वीडन चीफ बैठे थे बगल में. He asked actually during the visiting card exchange, how can I help you? I said, government has given me 5 crores, can you give me 5 crores money? Before I land in Delhi, the ABB chief from Bangalore is waiting in the Delhi airport to receive me. And next day there is an MOU signing, and third there is 5 crore grant. So this is what actually always God happened to be very kind to me and bringing, this could be the first real example of private partners money flowing to academic campuses. And this is what the system, as you look, where there is a battery which is in the center, electrical department in the right, we have huge diesel generator in the campus also. 100% हम डीजल से कैंपस चला सकते हैं. तो मेरे पास डीजल है, मेरे पास पीवी है, मेरे पास ग्रिड है और मेरे पास बैटरी भी है. तो चारों तरह की kind of 4 different type of resources. But how do I optimize? That has become a question. तो ये implementation होने के बाद हमने लैब में टेस्ट किए, उसको रियल टाइम बैटरी लगाए, उसको चार्ज भी किए और 4 साल से without any fault things are happening. But I'm very scared to tell that, क्योंकि जब भी मैं कुछ अच्छा खासा क्लेम करता हूँ डायस में और घर जाने के बाद ऑपोजिट हो जाता है, जैसे ब्लैकआउट हुआ था. So I touch wood and swear that things will go normal. But one interesting thing, suddenly I called my research team. All credit goes to my research scholars. Okay, there are 2 dozens of research scholars even working today. मेरे को लगा कि एक्चुअली हमने गलत डिसीजन ले ली. बता सकते हैं क्यों? 10 करोड़ इन्वेस्टमेंट के बाद एक पॉइंट पे लगा गोंद साहब कि हमने गलत डिसीजन ले लिए, क्योंकि मेरे पास लोड 70 है, 111 है और सोलर 70 है, तो सारा 70 अनिता मैडम हम तो ऑब्जर्व कर पाएंगे, तो बैटरी की क्या जरूरी है? तो मैंने कुछ गलत कर दिया, इसे मेरे को महसूस हुई. बट लेटर ऑन आई रियलाइज कि दिस 70 किलोवाट ऑफ पीवी which is available to me not at 10 o'clock or 11 o'clock, they are available to me from 6 AM during summer season. तो 6 बजे actually the department is not ready to utilize even that 70 kilowatt of PV which is available to me. तो हमने क्या किए, जो 70 kilowatt 6 to 9 before the department begins, वो 200 किलोवाट आवर एक्चुअली हमारी बैटरी फुली चार्ज रहता है और शाम को एक्चुअली वो डिस्चार्ज रहता है एक्चुअली. सो happened to be a very lucky moment, even though we took a decision which is not very smart decision, but today it is working extremely well. So ये होने के बाद, this is the battery, as you could see, 5 minutes, thank you. So as you could see, this is happening. Very quickly I am getting into the next area. So this is what my laboratory facility, certainly it is one of the world class facility. Most of the researchers across the world have visited the lab and appreciated that there is something concrete that need to be appreciated. तो ये जो facility आप देख रहे हैं, I will take little bit of credit here. The last corner box is power amplifier. We are the first institution in the country to have this device placed and operational. And I myself visited Germany, spent a week time, designed and manufactured this first amplifier and imported to India. And today probably we have 20 of them which is working operation. The important role of this amplifier that you can carry out real-time experimentation before you go toward the field deployment. So the third example is my AI school, and in that, as you could see, this is a beautiful example where the load is 70, the rooftop PV is 96, means we need to have the storage devices, otherwise 26 kilowatt hour की actual energy वो खराब हो जाएगा. तो ये डिसीजन हमारी काफी अच्छा रहा, जहाँ मैंडेटरी था, दूसरी जगह पे थोड़ा सा एफिशिएंट नहीं था, बट स्टिल वी आर एबल टू मैनेज. सो आज की डेट में दोनों माइक्रोग्रिड्स आर ऑपरेशनल, बट दिस टाइम आई हैव नॉट गॉन फॉर ABB as a sponsorship because they do have some technology right, Hitachi Power do have some technology right, so they are not very comfortable in sharing their all technology with us. तो हमने एक टेक्नोलॉजी जो दूसरे डिपार्टमेंट में लगाए, जहां DST की फंडिंग रहा, और एक स्टार्टअप को हमने चूज किए, जहां हमारी टीम मिलते हुए उस टेक्नोलॉजी को डेवलप किए. So now this technology is in-house, it is ready, which can be shared with all academic campuses of the country, because all the academic campuses do have solar, all the academic campus do have little bit of support from government, and all the academic campus do have similar scenario the way we experience. So keeping in mind, this technology need to be very quickly disseminated to other campuses with help of Department of Science and Technology. So this is what the technology is all about. Now, what is next challenge? You may be thinking, ये तो सब कुछ हो गया है, आगे क्या करना है? मेरे पास actually at least next 10 साल के लिए काम बचा हुआ है. What is that? This is the real time testing we have done. जब हमारे पास actually excess PV होता है, बैटरी उस टाइम चार्ज करता है कि नहीं, वो चेक करना भी जरूरी है. So I requested my scholars to give a screenshot that whether it is operational, and we could see whenever there is a excess energy, the battery is hungry to charge. Whenever there is sort of energy during evening hours, the battery is ready to discharge. So the last conclusion, what I see the future scope for all my young friends, we have 2 microgrids and tomorrow we'll have 5, 10, 100 and 20,000 microgrids. But it is not necessary that each and every microgrid is operating in the same fashion. Now, can 2 microgrids communicate to each other? Can the battery of a particular microgrid being charged by the PV of the other microgrid? Means, can my PV panels of a particular department charge the battery of electrical engineering department and vice versa? If you can do that, probably that is a success story I can see. So, हम actually invest करेंगे, millions of microgrid एक दिन देश में होगा, जरूर होगा sir, सोम साहब? Millions of microgrids इस देश में होगा, लेकिन जब वो communicate नहीं करेंगे, हम efficiently utilize नहीं कर पाएंगे. So the next challenge before us is how do we communicate and charge and discharge not only for your own microgrid, but to your neighbor microgrid. So with this future remark, I'm stopping here. Thank you very much for your wonderful intention, listening to me patiently. Thank you. 1 or 2 questions if you have in mind. If not, during lunch hour, we can discuss. 1 question, yeah. Excellent. I think this question, because I'm coming here from IIT Kanpur, yesterday I delivered a keynote address. I don't know, you were there in IIT Kanpur? Exactly the same question has been asked in IIT Kanpur. We all electrical engineers are not focusing at this point of time, and we have limited expertise for safety. Currently, the 30% of the truck size battery is being utilized with lithium battery locations. We have actually a continuous air conditioning system which is running, as well as we have an alarm system. If the temperature is beyond a particular point, an alarm will be raised in my laboratory. And the third, actually we have proper packing technology at this point of time. But those technologies being not indigenously developed, we are mainly focusing on system integrated evacuation of PV and storing in battery and further evacuation of battery. So that is what the aspect is. But this is a good question. We need good experts in this country to take care of this. Thank you. Please. No. No. Again, I told you, no, because we only disseminate PV energy to battery, and the battery will disseminate to the system. जब वो system से ज़्यादा हो जाएगा, उसके बाद वो grid को जाएगा. So that means at this point of time we have only 400 kilowatt hour, which is 10% of the total load. तो अभी grid के लिए कोई challenge नहीं है, लेकिन आगे आ सकता है. नहीं उसमें नहीं कोई issue नहीं. नहीं, we have technology. No worry. We'll talk more in detail. So I think thank you very much, and thank you for giving me an opportunity to speak here.
Thank you very much, sir, for inspiring lecture and the pioneering work done by you and your team. Moving on to the next keynote address by Professor Kamal Kishore Pant. Professor Kamal Kishore Pant is the director of IIT Roorkee. He is a distinguished academician and researcher with over 35 years of experience. His groundbreaking research spans green catalysis, CO2 capture, biomass conversion, and green hydrogen, including the successful development of coal to methanol plant. May I request Professor Pant sir to take over. Thank you.
So very good morning to all of you again, and thank you, Mr. Chairman, for providing me the opportunity and the DST for inviting me for this talk. already you have listened to Professor Padhi, who has talked about how the battery grids, electrical engineering related applications. I'm just talking a challenge which is related to the sustainable biomass utilization and which is yet to be experimented for a commercial plant. So if you look at this, the entire, right, when we talk about the availability of biomass challenges, people talk in terms of sustainability. So what do you mean by sustainability? And we were discussing a lot of things in terms of the societal, right, when we talk about the happiness. So many things when you look at, we need to understand that what is the need for this, right? Since morning, we are talking about net zero. We are talking about how much carbon dioxide is to be reduced and what is 2070 vision and 2047 vision. So many things are here. You see that when you look at your negative carbon, when you talk about by 2070 or after, how to achieve that, for that either we have to look at the battery or we have to look at something like solar and maybe other renewable energy sources. Nuclear is one of the best options, but thorium is available also in the country, and probably that would be one of the best options for the future. Because when we talk about these kind of sources like solar, EV, unless you have the solutions for the safe disposal and recycling of these kind of materials, we are still not getting the sustainable solution for this. So that is again a big challenge, that how our future would look like when we look at 10 to 15 years the battery life is over. Are we able to refurbish that and are we able to reuse it? That is again a challenge, and we need to find out a solution for that also simultaneously. So this is what we are talking, and how the India is looking like. You see, the third largest of the CO2 emitter, 3.9 gigawatt is the carbon dioxide which is already there. 1/3 of the carbon dioxide is to be reduced by 2030. All those things have been mentioned several times. And at the same time, when you look at the energy demand, because all these things what we are talking, 90% we are dependent on the fossil derived feedstock as of today, and we are saying that by 2030, 500 gigawatt of this renewable energy will be there out of 1000 gigawatt total energy. So still we are moving towards a kind of renewable, but also we are dependent on the fossil derived feedstock also. So you see that, right, the economy we are talking $10 trillion, and that is how are you going to achieve from $4 trillion to $10 trillion is a big challenge. Second thing is that when you talk about the energy requirement, just 40%, more than 90% fossil, which I am saying is reached by refinery, petrochemical and several other applications. That is again a big challenge. Lot of things when you talk about per capita, right, energy consumption is again 0.6 tons of oil equivalent, and we need to find out what is the substitute for that. We are talking the solar, we are talking wind, we are talking lot of other alternative energy sources, but at the same time we need to also look forward some kind of the renewable, which is a kind of biomass which is available in the country, and still this 200 billion ton of the biomass is unutilized, and that is again a challenge what you see in for the future. So Paral burning, all of you have seen the right examples, Delhi, smog and all these things are there, and so we have to find out the solution, right? So couple of these things which are mentioned here in terms of carbon mitigation, conventional versus alternative. So as right, the coal to methanol plant, IIT Delhi team, and I was there at IIT Delhi. We have set up this 1 TPD plant because India has 240 billion tons of the coal, and we need to find out our resources utilization. But that coal utilization itself will require that, because you are talking a kind of grey hydrogen which is coming from coal to hydrogen plant if you are getting, or coal to methanol, you have to look at the carbon dioxide which is coming out of that and again find out the solution for its conversion. So team is working on that. So this is the first thing where you talk about you have to get rid of the carbon at any cost, and that should be a kind of reducible when you talk about the commercialization of the technique. So that is a challenge. Second one which is now looking right, lot of things we are looking, the carbon dioxide which is coming. You know the traditional methods are available with the chemical engineers or other engineers, that you have the Fischer-Tropsch, Sasol in 80 years, right, when you talk about 100 years now almost, right, they developed this coal to liquid fuels. Lot of these things are in China, these are available, and they are looking forward in the carbon dioxide capture also. So that is where you have the carbon dioxide, you convert it into methanol through hydrogenation, and that is also where at IIT Delhi team and Thermax, and we are also a partner of that. We are looking the second part of this with the support of Department of Science and Technology for converting CO2 into methanol and dimethyl ether. But third thing which I have shown here is more important for the future. You see that we are talking a large amount of biomass which is available, and also it can become a revenue generation model for the farmers in the areas where the wetlands are there or where the crops are not being cultivated. The energy crop can go if we find out the solution with an effective way, because if you look at the total life cycle assessment, the biomass is considered as one of the a kind of a green fuel, and that is where when you convert this biomass into fuel, or if you convert it into hydrogen, that would be a kind of green hydrogen or green fuel, and that is where the third part where we would like to focus for the future, and that is the need of the hour also. So lot of things you see that, right? Biohydrogen I am talking, right, today, which is still yet to be developed in terms of the technology when you look at. Renewable will be a key, but still the R&D stage, so we need to work for that. These two are the green hydrogen. But if you look at the other three, whether it is natural gas, you can convert into blue hydrogen. So you must have heard the 7, 8 colors of the hydrogen which have come nowadays, right? Even people are talking white hydrogen also. But the main thing which we look at for the future, either you have the electrolysis of the water, which may be costly. Using the nuclear energy, you can reduce the price, but still a lot of things are to be done. The first thing is little bit, right, available and can be done with slight, right, change in terms of the existing technology, that is possible. But the gray hydrogen or brown hydrogen is not at all acceptable for the future. We need to convert it into a kind of blue hydrogen with carbon capture, and that is acceptable to the society. So this is where the example, everybody talks about Delhi, right? But this is not only Delhi, other parts also, because of the stubble burning, lot of issues coming. And stubble burning is happening because we are not able to provide the solutions to our farmers. We need to give a solution that it should be, when the harvesting is done, the crops should be compacted and taken, right, all these harvested biomass should be collected and taken to some other place. So that is where the societal awareness becomes very, very important, and there should be the smaller, what we call decentralized units, which can collect this kind of the, whether it is paddy, bagasse, rices, whatever, collect it and take it to the some other level from where it can be converted. If this is done, this 91% of this carbon dioxide which you see, that can be captured effectively, and also the life cycle assessment, because this plant material itself, they are taking part of the carbon dioxide, so you can call this hydrogen as a gray hydrogen. The right hand side, the graph which is showing, right, the amount of crop produced stubble burnt, and that gives you the idea about that how much, right, the waste which is being generated in terms of millions of the ton, because this is around 200 billion ton of this kind of agro residue which is coming and being burned by the farmers in the land, and that is creating in terms of the smoke formation, especially during October onward, because that is the peak time when the harvesting is done. We can find out the solution, and this is where I think little bit technologies are available, but commercialization of these technologies are to be done. So this is one of the, right, slides where I would like to just give some picture about how biomass can be, right, all of you know about this biogas. That is also one of the ways you can convert the biogas, you can crack it and you can convert it into hydrogen. So I'm focusing mainly today hydrogen, and there are several other ways also, like where low temperature and high temperature biomass conversion technologies. Several technologies we have developed also in our lab, where a kind of petrochemical raw products can be developed from this kind of biomass material, because it is nothing but carbon, hydrogen, oxygen and nitrogen. You understand the chemistry, and that chemistry can be utilized by the chemical engineer and then transform the technology. So these kind of biomass can be converted to ethanol or hydroxymethyl furfural, levulinic acid, series of the lubricants for the petrochemical or the oil industries. So this is what I was asking, or the question, that do you think that biomass is a sustainable green energy or sustainable green hydrogen, which always a debate right? Because people talk about how much carbon dioxide is coming from this. When you do the biomass gasification, 1 ton of biomass will give you 2 tons of the carbon dioxide. So lot of LC analysis is very, very important for this. But what you see the first point, right? This, if you compare with respect to, if you don't convert it, the methane which is coming, that is 20 times more the global warming potential gas. So that's the, it means the biomass, if you look at into the hydrogen, that is considered as a green hydrogen, and that is where the potential in terms of this. And when you talk about gasification, thermal reformation, pyrolysis, these can extract the hydrogen from the biomass with carbon part that can give you green color. So sometimes you can have the biochar, which can be used as a soil fertilizer, so carbon can be captured there, and you have the oil which can be reformed and you can convert it into series of the